Hi students, in this class we are going to solve a numerical problem on the SAG calculation of transmission lines. We have two towers of height 30 meter and 90 meter. They support a transmission line at water crossing. The horizontal distance between the towers is 500 meter. The tension in the conductor is 1600 kilogram. We need to find out the minimum clearance between the conductor and water. We also have to find out the clearance at the midway between the two supports. The weight of the conductor is 1.5 kilogram per meter. The bases of both the towers are at water level. This is the figure representing the particular numerical problem. This is our curve which represents the conductor, which has an equation y is equal to wx square divided by 2t. This is the origin. The coordinates are 0, 0. The distance of this tower with respect to the origin is x1. The distance of the right side tower with respect to the origin is x2. Here the SAG, which is the distance between the point of support and the lowest point on the conductor. This is S1. The SAG with respect to the right side tower is S2. Here the height of the first tower is 30 meter. The height of the second tower is 90 meter. So this distance is h is equal to 90 minus 30, which is equal to 60 meters. This is also equal to S2 minus S1. This is also equal to S2 minus S1. So we can write S2 minus S1 is equal to 60. In this equation, if you substitute a particular value of x, you will get the corresponding vertical distance y. For example, if you substitute x1, you will get the vertical distance s1. So we can write s1 is equal to w x1 square divided by 2t. Similarly, if you substitute this horizontal distance x2 with respect to the origin, then you will get this vertical distance. This is S2. So S2 can be written as W x2 square divided by 2t. These are the parameters given in the problem. We can write S2 minus S1 is equal to 90 minus 30 is the difference between the two towers. It's equal to 60 meter. We can also write S2 minus S1 is equal to W x1 square divided by 2t minus W x2 square divided by 2t. This is equal to 60, or W by 2t into x2 square minus x1 square is equal to 60. This is in the form of a square minus b square, which is equal to a minus b into a plus b. So W by 2t into, here it is x2 minus x1 into x2 plus x1. This is equal to 60. x2 plus x1 is the distance between the two towers. L is equal to 500 meters. W is equal to 1.5 kilogram per meter. That is 1.5 divided by 2 into the tension, the conductor is 1600 kilogram. That is 1600 into x2 minus x1 into 500 is equal to 60. Or we can write x2 minus x1 is equal to 60 into 2 into 1600 divided by 1.5 into 500. So x2 minus x1 is equal to 256 meters. And x2 plus x1 is equal to the distance between the two towers. It is 500 meters. Now let's solve these two expressions. 1 plus 2 gives 2x2 is equal to 500 plus 256, it is 756. So x2 is equal to 756 by 2, which is equal to 378 meters. Now substitute this in the second equation. 378 plus x1 is equal to 500, or x1 is equal to 500 minus 378. This is equal to 122 meters. Now let's find out the two SAG. S1 is equal to W x1 square by 2t, which is equal to 1.5 into x1 is 122 divided by 2 into 1600. This is equal to 7 meters. S2 is equal to Wx2 square divided by 2t, which is 1.5 into x2 equals 378 divided by 2 into 1600. This is equal to 67 meters. Now we got the two SAG values, S1 and S2. Now we need to find out the minimum clearance between the conductor and water. This is the minimum clearance, which is equal to the height of the left side tower 30 minus the SAG S1. S1 is equal to 7 meters. So this is 30 minus 7, which is equal to 23 meters. This is the minimum clearance between the conductor and water. So this is equal to 23 meters. Now we need to find out the clearance at the midway between the two towers. Suppose the midpoint is this one. So on the left side we have 250 meters, on the right side also we have 250 meters. The total distance between the two towers is 500 meters. This is the clearance at the midway, and this distance is equal to 23. This is the minimum clearance. We just calculated this value, and now we need to find out this vertical distance. Let this value be S mid. In order to find out this height, we need to substitute the corresponding x in this equation. Y is equal to wx square by 2t. It's the equation of this curve. If we substitute this distance, the horizontal distance with respect to the origin, suppose this is x3, then you will get S mid. So S mid is equal to W into x3 square divided by 2t. And this x3 is equal to, the total distance is 250 meters minus this distance, it is 122. So x3 is equal to 250 minus 122, which is equal to 128 meters. So let's substitute this value in this expression. It is 1.5 into 128 square divided by 2 into t is equal to 1600. This is equal to 7.68 meters. So S mid is equal to 7.68. And this distance we already know. This is equal to 23 meters. That's the minimum clearance. We calculated the value. So the clearance at the midway between the two transmission towers will be equal to S mid plus the minimum clearance 23. So this is equal to 7.68 plus 23. This is equal to 30.68 meters.